Pluto, a distant and enigmatic celestial body, was once a part of our solar system's planetary family. But recent alarming statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into public attention. They've made a startling revelation. Pluto might be on a potential collision course with Neptune. However, how could such an event occur, and what might the outcomes be? Is this a rare cosmic anomaly, or is there something more to this forthcoming cosmic impact? Join us as we explore the possibilities of a potential Pluto-Neptune collision. Pluto, once classified as a planet but later redefined as a dwarf planet due to its strange orbit, continues to captivate the scientific community. According to recent studies by leading scientists, Pluto's trajectory is dangerously close to Neptune's orbit. Renowned astrophysicists like Tyson and Kaku are raising alarms about the potential for a catastrophic collision between these planets, a scenario that could pose a significant danger to Earth. But how could such an event come to pass? Unlike any other planet in our solar system, Pluto's journey around the Sun is strikingly unusual. It takes a staggering 248 years to complete just one orbit. Since its discovery in 1930, Pluto hasn't even finished one full revolution, adding to its mystique. But Pluto's orbit isn't just slow, it's also highly elliptical, drastically different from the more circular orbits of the larger planets. To complicate things further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path far more extreme than that of other planets, adding layers of complexity to its motion. One of the most fascinating aspects of Pluto's orbit is its interaction with Neptune's. For roughly 20 years of each orbit, Pluto comes closer to the Sun than Neptune does, defying what we'd expect based on the planet's relative positions in the solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other celestial bodies, particularly the gas giants. The study of Pluto's orbit began shortly after its discovery. Early astronomers were puzzled by its unusual path. Unlike other planets whose orbits are relatively aligned with the ecliptic plane, Pluto's orbit stood out due to its steep tilt and elliptical nature. The realization that Pluto's orbit crosses Neptune's was a major point of scientific curiosity. Despite these irregularities, the stability of Pluto's orbit is a remarkable feature of orbital mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding how three celestial bodies move and influence one another through gravitational forces. Predicting their paths is a complex task, and this is where terms like AIML libration, scope libration, and VZK wobbling become relevant. The concept of AIML libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring their paths never intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune or another large planet, it is located above the plane of their orbits, offering additional protection from potential collisions. Another key factor is VZK wobbling, named after researchers VZ and K, who studied how celestial bodies interact via gravitational forces. This phenomenon explains how Pluto, Neptune, and the Sun's gravitational pulls influence one another, helping keep Pluto's path stable despite its seemingly erratic behavior. Though Pluto's orbit may appear unpredictable, this wobbling mechanism helps maintain its steady path over long time scales. These complex forces help ensure Pluto's orbit remains stable, preventing it from crashing into Neptune or straying wildly. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this gives us deeper insight into Pluto, our solar system, and even distant celestial bodies and their stars. Mathematical simulations conducted in the late 1980s revealed that, although Pluto's orbit has these stabilizing factors, it is still chaotic. Small changes in its initial conditions could lead to significant variations over millions of years. Despite this inherent chaos, Pluto's orbit remains stable over fairly long periods, effectively keeping any potential disruption in check. Recent computer models have provided new insights into how the gravitational influences of giant planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. These models show that Pluto's relationship with Neptune is resonant. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This relationship helps stabilize Pluto's orbit. But Neptune isn't the only force at play. Jupiter's gravity plays a key role, as does Saturn's, providing additional balance. These simulations show that Jupiter's gravitational pull alone is strong enough to ensure Pluto stays in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its path, avoiding catastrophic collisions or other disruptions. These gravitational forces are crucial for maintaining order within the solar system. Without them, the system would be far more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. Understanding Pluto's orbit is essential to gaining a clearer picture of our solar system's dynamic nature. Pluto's case serves as a prime example of how even the most seemingly risky orbits can achieve stability through the intricate interplay of gravitational forces. It also underscores the importance of continuous observation and exploration to better understand our place in the universe. The study of Pluto and its orbit illustrates the unpredictable nature of celestial mechanics. The concept of orbital chaos, which refers to the extreme sensitivity of a body's orbit to its initial conditions, is clearly visible in Pluto's case. Even the smallest change in Pluto's position or speed could significantly alter its orbit over time. Simulations have played a pivotal role in helping researchers understand Pluto's motion. These computer models use complex mathematics to simulate how Pluto and other celestial bodies interact gravitationally. By tweaking small variables, astronomers can see how tiny modifications can dramatically alter Pluto's long-term orbit. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. While it can be stabilized by factors like AIML and scope libration, it can still be erratic. Even slight variations in Pluto's initial position or velocity can cause dramatic changes in its orbit over long periods. Regardless of the apparent chaos, Pluto's orbit remains remarkably stable, enduring for billions of years. This demonstrates that, while its path may seem chaotic, there is an underlying order to it. Predicting celestial events, especially those involving chaotic orbits like Pluto's, is a major challenge. The unpredictable nature of these systems means that long-term predictions are fraught with uncertainties. While simulations are invaluable tools for understanding and forecasting the motion of celestial bodies, they also highlight the limitations of our predictive abilities. Any slight error in initial conditions can lead to vastly different outcomes, making precise predictions nearly impossible. The chaotic nature of Pluto's orbit serves as a reminder of the constantly evolving and dynamic universe we live in. While we make great strides in space exploration and understanding the cosmos, Pluto's orbit reminds us of how much remains unknown. Understanding the gravitational interactions of large planets on Pluto provides critical insights into the broader dynamics of the solar system. Gadget. It reveals how the positioning of every planet can have far-reaching outcomes, influencing the stability and trajectory of other bodies in the system. So why are astrophysicists raising concerns about a likely collision between Pluto and Neptune now, after all these years? Neil deGrasse Tyson, a leading astrophysicist and an influential figure in popularizing the study of cosmology, offers an insightful angle. Tyson, known for advocating the reclassification of Pluto as a dwarf planet, believes that this shift reflects our ever-growing knowledge of the solar system. He does not view Pluto's reclassification as a demotion, but rather as an evolution in our understanding of the several bodies orbiting our Sun. Tyson's approach to celestial mechanics is rooted in continuous learning. He sees Pluto's erratic orbit as a sign of how much more there is to discover in space. The fascination with unknowns, such as the potential for catastrophic events between Pluto and Neptune, continues to captivate scientists and the public alike. Tyson's predictions about Pluto's fate consider its particularly irregular orbit, acknowledging that anything from a near flyby to a catastrophic collision remains within the realm of possibility. Michio Kaku, another renowned physicist, joins the chorus of experts raising concerns about Pluto's long-term future. Kaku, recognized for his work in theoretical physics, delves into the mathematics behind the potential interactions between Pluto and Neptune. His theory suggests that even while Pluto's orbit seems stable today, its future remains uncertain. He warns that over time, even minor shifts in the gravitational forces between Pluto, Neptune, and other planets could lead to a catastrophic event. Kaku's predictions underscore the vulnerability of Pluto's orbit, regardless of its current balance. As we continue to probe the cosmic mechanisms at play, it is critical to consider the fate of Pluto's orbit. Even though current models suggest that a collision with Neptune is unlikely in the near future, the unpredictable nature of celestial dynamics means we can never completely rule out such a possibility. Gravitational interactions with other celestial bodies will continue to shape Pluto's trajectory, and even the slow transformation of the Sun into a red giant, and its eventual collapse into a white dwarf, could alter the gravitational landscape of the solar system, potentially affecting Pluto's orbit. While the likelihood of Pluto colliding with Neptune anytime soon appears remote, the inherent uncertainty in predicting celestial dynamics over such vast timescales means that anything is possible. The forces at play in orbital mechanics are powerful and intricate, and even the slightest change can accumulate over billions of years, potentially leading to major shifts in the orbits of distant objects. This uncertainty in space exploration brings us back to a core principle. The more we study the universe, the more we realize how much remains unknown. The study of Pluto and other remote objects in our solar system continues to challenge our understanding of planetary orbits, gravitational interactions, and the fundamental laws that govern the cosmos. As scientists continue to study Pluto and Neptune, new information may either reinforce or challenge our current theories. Although the concept of a catastrophic encounter between Pluto and Neptune may seem far-fetched, it serves as a reminder of the mysteries that space still holds. As our tools for space exploration improve, providing us with more accurate ways to simulate, predict, and study these cosmic phenomena, the potential for a collision or near miss between Pluto and Neptune remains a compelling example of the complexity and unpredictability of our solar system. Whether such an event will ever take place is unknown, but it highlights the ever-changing nature of our cosmic environment. The story of Pluto's orbit invites us to think beyond what we currently understand and to embrace the mystery of space. It challenges us to study the universe with fresh perspectives and to remain open to the surprises that lie ahead. As scientists continue to unravel the mysteries of the cosmos, we are reminded that we have only scratched the surface of what the universe has in store. Whether Pluto and Neptune will continue to orbit safely or one day experience a cosmic collision remains an open question, one that only time and further discoveries will answer. As we move forward in our understanding of the cosmos, the tale of Pluto's orbit serves as a symbol of the mysteries that continue to perplex and excite scientists. The possibility of a collision or close encounter between Pluto and Neptune, though unlikely in the near future, is a reminder of how much we still need to learn about the vastness of space. These celestial events, no matter how improbable they may seem, invite us to keep questioning the workings of the universe and the fundamental forces at play in the ever-expanding field of astrophysics. There is always more to discover. As we delve deeper into space exploration, the tools and techniques used to study distant worlds like Pluto are improving. Advanced telescopes, space missions, and more sophisticated computer simulations allow researchers to track these celestial bodies with extraordinary accuracy. These innovations offer new insights into the mechanics of planetary motion, gravitational interactions, and the long-term stability of our solar system. One of the most exciting developments in the study of Pluto and its orbit is the ongoing advancement of observational technologies. New space missions are constantly being launched with the goal of exploring distant objects in the solar system. These missions, such as the New Horizons probe, have provided valuable information on Pluto and other objects within the Kuiper Belt, offering a better understanding of the characteristics of these far-off worlds. With each new discovery, our understanding of these distant bodies becomes clearer, and we gain greater insight into the processes that govern their movement. The fact that Pluto remains an object of intrigue and study, even after its reclassification as a dwarf planet, speaks to the continuing fascination with this distant world. Pluto may no longer hold the title of planet in the eyes of the scientific community, but it still occupies a significant place in the public imagination. Its reclassification has sparked debates about the definition of a planet, the complexities of our solar system, and the ways in which our knowledge of space is constantly evolving. This ongoing exploration of Pluto's path reminds us of the fluid nature of scientific knowledge. What we understand today may change tomorrow as new data emerges and new theories are proposed. The potential for a future collision between Pluto and Neptune is a possibility that cannot be dismissed entirely, but it also reflects the broader issue of unpredictability in space. The very nature of the universe is such that we can only predict with a certain level of confidence, and even the most carefully crafted models can be overturned by new findings. The pursuit of knowledge in astrophysics is driven by the desire to comprehend the fundamental workings of the universe. By studying Pluto and its relationship with Neptune, scientists are not only examining the specific dynamics of these two planets but also gaining a deeper understanding of how gravitational forces shape the motion of all celestial bodies. The insights gleaned from these studies have far reach. The study of Pluto's orbit also highlights the importance of collaboration in the scientific community. Astrophysicists, astronomers, physicists, and mathematicians all contribute their expertise to the analysis of Pluto's movements, each offering a unique perspective on the problem. This collaboration has led to the development of more refined models of planetary motion and a better understanding of the delicate balance that keeps the solar system in harmony. Even though Pluto's potential collision with Neptune may seem like a far-off possibility, it serves as an important reminder of the ongoing challenges we face in predicting the behavior of distant objects in the universe. The chaotic nature of celestial orbits means that even the most stable-looking systems can be subject to unexpected, dramatic shifts. As we continue to monitor Pluto and other distant bodies, it is crucial to remain open to the unexpected and to constantly refine our models based on new observations and discoveries. As our exploration of space progresses, we are continually confronted with the immense unknown. The tale of Pluto's orbit exemplifies the sense of wonder and curiosity that drives us to explore the universe. Even as we learn more about the planets and moons that make up our solar system, we are reminded that there is still much to discover. The potential for a future Pluto-Neptune collision, though uncertain, encourages us to keep seeking knowledge and to remain ever curious about the mysteries that lie beyond our reach. In the grand scheme of the cosmos, the movements of Pluto may appear insignificant, but they serve as a microcosm of the larger forces at play in the universe. The gravitational dance between Pluto, Neptune, and the other planets is a small-scale example of the intricate and interconnected nature of celestial mechanics. It reminds us that everything in space is in motion and that even the smallest objects can have a profound impact on the larger systems they are part of. Ultimately, the story of Pluto and its potential interaction with Neptune is not just about these distant worlds, but about the broader quest for knowledge and understanding in the field of astrophysics. It is a reminder that no matter how much we learn, there is always more to discover. The universe is full of surprises, and as technology advances, we will continue to unlock its secrets, one revelation at a time. The possibility of a collision or close encounter between Pluto and Neptune, while unlikely, serves as a powerful symbol of the mysteries that still lie ahead in the field of space exploration. The fate of Pluto's orbit is uncertain, and we can only wait and see how the forces at play will unfold over time. But one thing is clear: the more we learn about Pluto, Neptune, and the rest of the universe, the more we realize just how much there is still to discover. As we continue to study Pluto's movements, the gravitational consequences of other planets, and the intricacies of orbital mechanics, we are reminded of the vastness and complexity of the universe. The story of Pluto is far from over, and with each new discovery, we inch closer to understanding the true nature of the solar system and the universe at large.